This is a tutorial on complex numbers. Complex numbers include all real numbers, rational or irrational, but complex numbers also include imaginary numbers. Now, imaginary numbers come from when we try to take the square root of a negative number. Up until now, we've always said we can't take the square root of a negative number because there's no number that you can multiply by itself that would end up negative. If you multiply 2 times 2, you get 4. And negative 2 times negative 2 is a positive 4. So there's no way you can multiply any number by itself and get a negative. It'll always end up positive. So what happens if you try to take the square root of a negative number? Well, if I have the square root of a negative 49 here, I can rewrite this as the square root of 49 times negative 1. And if I can rewrite it that way, that means I can also rewrite this as the square root of 49 times the square root of negative 1. Well, I can take the square root of 49. That's just 7. So this would be 7 times the square root of negative 1. Now, I still can't take the square root of negative 1. Again, it's a negative number. And that wouldn't make any sense. But I'm going to call this square root of negative 1, I'm going to call it I. I is our imaginary unit. So if I have the square root of negative 49, that's just 7i. If I had the square root of negative 36, that would be 6i. So now that I've figured out how to take this square root of a negative number and turn it into this imaginary number, 7i, 6i, this is where complex numbers comes from. Now there's a standard form of how we write complex numbers, and that's this a plus bi. Now a and b are just integer or rational or real numbers, but we call this a out front the real part of our complex number. And we call this bi the imaginary part of our complex number. And it's called the imaginary part because notice it has our imaginary unit in it, I. Examples of complex numbers then would just be 3 plus 7i or negative 4 minus 6i. It could also be 2 plus the square root of 2i. These are all complex numbers because they contain a real part and then an imaginary part. But since complex numbers have both a real and an imaginary part, how do we add and subtract complex numbers? Well, we do this by adding and subtracting the real parts and then adding and subtracting the imaginary parts. Another way to think of this is just pretend for now that I is a variable. And then you can just add these like I was a variable. So if I had 2 minus 6i plus 3i, I would just add my like terms, or the terms with the I in them. So this would become 2 minus 3i. So 2 minus 6i plus 3i then is just 2 minus 3i. Same thing for subtracting complex numbers. You can just subtract the real parts and subtract the imaginary parts. Or you can again treat I like it's a variable. So if we were going to subtract 10 plus 2i, and 6 plus 6i, I would convert this. I would say this is plus a negative 1 times this number. Then I would distribute the negative 1 inside, and we'd end up with 10 plus 2i plus negative 6 minus 6i. Now I just add my like terms, or I add the real parts. 10 and a negative 6 would be a positive 4, and then 2i and a minus 6i would be a minus 4i. So 10 plus 2i minus 6 plus 6i would be 4 minus 4i. Now when you multiply two complex numbers, here we have 2 plus 5i times 7 minus 5i. Again, just treat I like it's a variable. Pretend it's a variable, and then you would just FOIL these numbers out. So you would take the first terms and multiply them together. You take the outside terms and multiply them together. Then the inside terms and multiply them together. And then the last terms and multiply them together. And when you do this, just pretend that I is a variable. So we would have 2 times 7 is 14. 2 times minus 5i would be a minus 10i. 5i times 7 would be 35i. And then 5i times a minus 5i would be minus 25i squared. Now let's look at this last term a little bit more closely. Here we have minus 25i squared. Now we've been treating I like a variable as we do this multiplication, but remember that I is equal to the square root of negative 1. So if I have the square root of negative 1 and I square it, well, that's just equal to negative 1. So whenever you see I squared, just remember that's equal to negative 1. So here this is really minus 25 times negative 1, or plus 25. So we'd have 14 minus 10i plus 35i plus 25. We can combine our like terms then. We'd have a 14 and a 25. That's 39. And then a minus 10i and a plus 35i would be plus 25i. So 2 plus 5i times 7 minus 5i is just 39 plus 25i. Now dividing complex numbers is a little bit different. This is more like rationalizing a root out of the denominator. And to do this, we're going to multiply this whole thing by its complex conjugate. And the complex conjugate just comes from the difference of two squares. Remember, if we have a squared minus b squared, this always factors into a minus b times a plus b. So here I have a 1 minus 2i in the denominator. That's a lot like a minus b. So what I'm going to do is I'm going to multiply this whole equation or expression by 1 plus 2i with 1 plus 2i over it. I can do this because 1 plus 2i over 1 plus 2i is some number over the same number, and that's always equal to 1. If I had 2 over 2, that's equal to 1. If I have the square root of 3 over the square root of 3, that's equal to 1. So I'm not changing the value of this expression by multiplying it by 1 plus 2i over 1 plus 2i, but I will get rid of the I in the denominator. So this is going to break down to 8 plus 2i times 1 plus 2i all over 1 minus 2i times 1 plus 2i. Now you have to FOIL out both the numerator and the denominator separately. I'm going to start with the numerator first. If I have an 8 plus 2i and a 1 plus 2i, 8 times 1 would be 8. 8 times 2i would be 16i. 2i times 1 would be 2i. And 2i times 2i is 4i squared. Now remember, I squared is always equal to negative 1. So this is 8 plus 16i plus 2i minus 4, because I squared is just equal to negative 1. And if I simplify this, 8 minus 4 is 4. 16i plus 2i is 18i. So this is my numerator. My denominator, I'm going to FOIL out next. I have 1 minus 2i times 1 plus 2i. 1 times 1 is 1. 1 times 2i is a positive 2i. Negative 2i times 1 is a minus 2i. And negative 2i times 2i is a negative 4i squared. But again, I squared is equal to 1. So this is 1 plus 2i minus 2i plus 4. Because a negative 4 times a negative 1 is just positive 4. Again, we add our like terms. 4 plus 1 is 5. 2i minus 2i is 0, so we just have a 5. So our solution then would be 4 plus 18i over 5. Or you could rewrite this as 4/5 plus 18/5 I. So to divide two complex numbers, you always just multiply by the complex conjugate, which is just the other form of our difference of squares. So if this was 1 minus 2i, then we multiply it by 1 plus 2i over 1 plus 2i.